Okay, so far so good? All right, we've done what we're going to do out of chapter 6. So in chapter 6, that was probabilities with normal distribution and central limit, and then finding values on normal distribution. So that's kind of the 3 different things out of that chapter that might be on your third test. All right, now we're going to start chapter 7. Now chapter 7 deals with something called confidence intervals, okay? So we're going to talk about that, but it's similar to chapter 6 in that in chapter 6, you kept ending up back at that normal curve problem. So it would be a little bit different every time, but kind of the same basic idea. That's the way chapter 7 is. Chapter 7's different kinds of confidence intervals. We're going to talk about confidence for proportion and percent and mean. Okay. Now let me kind of give you the general idea of what a confidence interval is. It's kind of a range of values. Have you ever been to the Mississippi State Fair and gone down Midway, and there's a person that usually wants to guess your weight, okay, for a prize? Now, why somebody would do that, I don't know, but hey, if you want to do that, that's fine. So what normally happens is if you decide to pay him $5 or whatever, he's going to try to guess how much you weigh, and then you step on the scale, and if he's right, then you lose your $5, and if he's wrong, then you win the prize. Now, really, he wins either way, because what he gives you for a prize isn't worth $5. Okay, but he doesn't have to guess your weight exactly. He had some wiggle room. And if I remember, it's about 5 pounds. So what would happen is he would write down his guess of your weight on a piece of paper, and then you would step on the scale and see what the weight was. So for instance, if you step on the scale and you weighed 120, all right, now remember, he gets 5 pounds wiggle room both ways. So that means, 120 minus the 5 pounds, that'd be down to 115, and then 120 plus the 5 pounds, that would be up to 125. So if you weighed anything between 115 and 125, then he wins, okay? And that just gives him, a higher probability of winning than if he had to guess a single value. All right, it's the same kind of idea with confidence intervals. Rather than having one number, you're going to have a range of values, okay? So let me kind of pull this PowerPoint up and we'll kind of talk our way through it. All right, so we're going to start today with proportion, and then next time we'll end up doing them for mean. Okay, so confidence intervals for proportion. All right, now, look what it says. A confidence interval is a range of values used to estimate a population parameter. Now, here's what I mean by that. Suppose you went and did a study. Maybe you were doing the average weight of, I don't know, 10th grade girls, okay? And so in your sample, you found that the average weight was 120. Now, would you feel confident saying that the average weight of all 10th grade girls would be 120? See, not quite as comfortable. I know my sample average was 120, but what about the population average? Okay, I would feel better if they gave me some wiggle room. So kind of like the example I talked about. Now, here's what I want you to notice. You're using a sample number to predict a population number. So in these confidence intervals, the symbols in the middle must be population symbols, not sample symbols. So that's why I have a mu and not an X bar, okay? So my sample mean was 120, but instead of saying that the average for all 10th grade girls is 120, I'd rather get a little bit of wiggle room. So I'd take my sample number and add a little bit and take my sample number and subtract a little bit. And remember, we used 5 pounds. So I'd feel more comfortable saying that the average weight is between 115 and 125 for all 10th grade girls, rather than saying that the average weight is exactly 120, okay? Now, proportion is going to be the same weight. If you did a study and found out the proportion of the sample was 4,500 hundredths, maybe that's the part that made a C in that class, okay? Now, remember, P's are just like probability. So proportion is just like probability. So P's and P hats are going to be numbers between 0 and 1, okay? So just make sure that we're kind of aware of that, okay? So here, that's why I've got a P instead of a P hat, because P is the proportion of the population. So again, it's going to be like P hat minus a little bit and P hat plus a little bit. So if I took that 4,500ths and I added 300ths, I'd get 4,800ths. If I took that 4,500ths and subtracted 300ths, I'd be down to 4,200ths. So instead of saying that the proportion of my population is decimal 45, I'd feel more confident if you gave me some wiggle room. Okay, so that's kind of how the confidence symbols are going to look. All right, so let's kind of go look at the next slide and kind of talk our way through it. All right. Now, when I ask you to do a proportion confidence interval, and that's what your homework is going to be on after this video, you're always going to write on your paper, P is between blank and blank. So a blank is less than P is less than another blank. Now that P is the proportion of your population. And what you're going to do, basically, the calculator is going to do the work. What the calculator is doing is taking the proportion of your sample and subtracting a little bit of error, and taking the proportion of your sample and adding a little bit of error. Now, this is the error formula in your book, but you don't have to learn it or use it because it's built into your machine. But I do want you to see what the calculator's doing. Excuse me, the calculator's taking the proportion of your sample. Now that's P hat. Now, just like probability, how do you get Q's when you know P's? Remember, Q is 1 minus P. So they would take 1 minus P hat to get Q hat. N would be the total, the group size. And then they put a Z-score there. So that's the way the calculator is going to calculate the error formula. All right, now confidence levels can be any percentage, but the most popular are 95%, 90%, and 99%. Now, this is not exactly what it is, but you can kind of think about it this way. If you were 95% sure that you were right, what if you wanted to be even more sure that you were right, like 99%? Would you want more wiggle room or less wiggle room? Do you see that you'd want more wiggle room? Because if I've got more wiggle room, I'm more likely to be correct. But now it's got to be a balance. All right, let me tell you what I mean by that. I'm 100% sure that the average ACT score is somewhere between 0 and 36. See, that's completely unhelpful, okay? But if I shrink it, if I say the average IQ score is somewhere between 21, ACT score is somewhere between 21 and 24, I'm not going to be 100% sure, and I'm going to be less sure, so maybe 80%, okay? So just remember, when you widen the gap, your probability goes up, your confidence goes up. When you shrink the gap, your confidence is going to go down. So as confidence levels increase, the interval would also have to increase or widen. All right, now let's go look at some problems and how you would work them. All right. When you're doing confidence intervals for proportion, one thing I want you to get in the habit of doing, we'll talk about in a minute when we work one, is you're always going to underline confidence interval of what? Because sometimes the problems are going to sound exactly the same. So you need to know, what are you doing a confidence interval for, so you know what to write on your paper. So if it's confidence interval for proportion, you're always going to put P between two blanks on your paper. Now the calculator is going to do all the work. You're going to go over here to your stat button. So not second VAERS, go to the stat button. It's to the left of your arrow keys. When you get to your stat button and you press it, you're going to go over to the right till you get to tests. Okay? Now scroll down. You have to scroll down for a while until you see 1 prop Z int. Okay? Now, several of these sound the same, so it's not 1 prop Z test, it's 1 prop Z int. So make sure you're on the right one. That prop stands for proportion, and that INT stands for interval. So I'm doing a confidence interval for proportion. Okay. Now, when you go down and you enter on 1 prop Z test, this is what comes on your screen. It's going to ask you for X and N and C. N's always your total. X is the number that you have, you'll see in a minute. And C level is confidence level, but just make sure that you change it to a decimal and you're going to hit calculate. Okay, when you do that, it's going to give you two numbers and a parenthesis, and those two numbers go in the blanks. Now, kind of a quick, upcoming thing that you might see, sometimes instead of saying confidence interval for proportion, they say for percentage. If they say for percentage, you're just going to change that decimal to a percent, but we know how to do that. All right, let me show you what I mean with an example. All right, this one's on kind of page 312 in your books. All right, so if you want to turn to it, you can. Okay, but I've kind of written it out here. It says one of Mendel's famous genetics experiments yielded 580 peas, with 428 of them green and 152 of them were yellow. So this is the way the problem would be worded. Find or construct a 99% confidence interval estimate of the proportion of green peas. So remember what I said, it says find or make a confidence interval of what? Of proportion. So I underline proportion because next time it's going to say mean. Okay, so you need to do the right one. Because it says proportion, that's how I know to put P. Because P is the symbol for the proportion of a population. It's between two blanks. So remember what we said, we're going to go over to stats and go over to test. And we're going to do 1 prop z int. Okay, 1 prop z int. Now, it wanted the proportion of green peas. So that's why my X value is the number that goes with the green. So 428. Remember, 580 is your total. N's always your total in every problem that we've ever worked. N's the total. Then what confidence level? So I go up here and it said it wanted 99% confidence level. So remember I said it's got to be a decimal, so make sure you put 0.99, not 99. Now when you hit calculate, this comes on the screen in a parenthesis. So this number goes in the blank on the left, and this number goes in the blank on the right. If you just box this parenthesis for your answer on a test, I'll count off. I want the answer written, P's between two numbers. Okay? Now, if it had said it wanted the estimate for percentage instead of proportion, I'd have worked the problem exactly the same way. The only difference would be I would change these decimals to percents by multiplying by 100. But notice the P is the same. Whether it's proportion or percent, it stays P. It's just the context of the problem. So if it says proportion, leave them decimals. If it says percentage, you have one extra step. Multiply those decimals by 100. But you see what I mean by the calculator does all the work? It's great. Okay, let's go look at another one just to make sure we're good. Oxycontin is a drug and it's used to treat pain. So this is number 20 out of your books on page 312. So in clinical trials, 227 people were treated with Oxycontin and 52 of them developed nausea. Okay, so the question says to construct a 95% confidence interval estimate of the percentage of Oxycontin users who develop nausea. So as soon as it says construct a confidence interval for proportion or percent, I put P and I have blanks on either side. Okay, so I have to know to put P between two blanks. Okay, now how do I know what numbers to put in the blanks? How did I get those numbers? Because I underlined percentage, I knew to go to stats and go over to test and look for 1 prop z int, confidence interval for proportion. Remember, X is your value. So it wanted the ones who developed nausea, so that's why I did 52. It could have said who didn't develop nausea. So you got to pay attention to the problem. N's always my total. So it told you there were 227 people in your study. Your confidence level, remember it said construct 95%, so I changed it to 0.95. And I hit calculate, and these two numbers came up in my parenthesis. So this number went in the blank on the left, this number went in the blank on the right. Now, if it had said construct a confidence interval for proportion, I would have boxed this and been finished. But it didn't say proportion, it said percentage, okay? So I had to multiply both of those numbers by 100, and so my final answer is this answer with the percents. Now do notice on your screen, it tells you that p hat is this number. Now, where did the calculator get p hat to be that number? Well, it took your 52 who were nauseous and divided it by the total. Remember, just like when you're doing probabilities, the total goes on the bottom, your number goes on the top. So it's just telling you back up here, all right? Let's go back and look. It's taken that proportion of that 0.22 and subtracting a little bit of error, and it's taking that proportion of 0.22 and it's adding a little bit of error. It used that formula to get your error, okay? So that's kind of how it got those numbers in the blanks. But for you to work the problems, it couldn't be easier, okay? So basically, remember when it's proportion, you put P between two blanks. You go over to stats, go over to test, pick one prop Z int, your X, your N, and your confidence level, and the calculator does all the work. But make sure you have P between two numbers for your final answer. Don't just put the numbers in a in a parenthesis, or I'll count off. Okay, so go try that homework. And again, if you're having trouble with anything, email me. Okay, we can set up a one-on-one Zoom meeting. You can snap a picture of your homework and say, I made a mistake and I can't find it, and send it to me, and I'll look at that picture and send you some feedback back. Just whatever works well for you. And remember, we have those Zoom meetings on Tuesday afternoons. If you'd like to ask me to work a question kind of, with other people, kind of like we do at the beginning of class. So let me know if you need any help.